Hey guys, welcome to Layla Teachers. Today we will be doing a topic on the conductive system of the heart, and we will split it in 4 different parts. So the first one is about the spread of the electric impulse. So we start with the sinoatrial node, which is in the right atrium, and it is the pacemaker of the heart. So obviously it is going to start the electrical impulse. From there, it depolarizes the atrium. So that's what the P in the electrocardiogram stands for. And once it's done that, it passes to the atrioventricular node, and from there it goes through the bundle of hairs to the Purkinje fibers and then to the ventricles finally. And one thing you should know is that it always only travels in one direction, so it cannot go the other way around. It has to start with the SA node. Sometimes if it's faulty, like we use a pacemaker, and then it goes on to the AV node, so that's what it starts. Moving on to the second point, we will speak about the action potentials and how they are brought about. So we have 2 types, like 2 pathways, you could say. So the first one is the fast one, and the second one is a slow one. There's only one difference between both of them, and that's in the first step. And there are 5 steps in total. So we have 5 phases. It goes from phase 0, 1, 2, 3, and 4. So phase 0 starts with the sodium influx. So because sodium is a positive ion, and it causes positive charge to enter, so we have a rise in the EMF and electromotive force, and it goes to plus 60 millivolts. And the difference is that there's a calcium influx in the slow phase. In phase 1, the sodium channels are inactivated. That means it has to decrease. So it goes from 60 millivolts to 0. In phase 2, we've got the calcium channels. So there's an influx of calcium, but that doesn't make it very positive. It just maintains the action potential. And in phase 3, we've got the period of repolarization. And from there, then we have a period of recovery in phase 4, which is, it goes negative from here because the potassium ions enter and sodium and calcium are gone outside. Moving on to the third part, here we'll speak about what the action potential actually does. So how does the heart contract, right? So it's the steps and the excitation, contraction, coupling. So first we have the action potential. From there, it goes to the cell membrane, right? From the cell membrane, it goes to the tubules. So they allow the action potential to pass through. So that's the second step. So there is the conductance, which increases the calcium ions. In the third step, you'll see that these calcium ions are stimulating more calcium release. It's called calcium-triggered calcium release. There's an invert calcium current, a lot of them, it gets triggered, and then this calcium that is there in the membrane is released from the sarcoplasmic reticulum, which is present in the muscles, and it's one of its functions is to store calcium. So this calcium binds to troponin C, which you know is in the sarcomere, and this once it binds, it changes its shape, conformation, and then it lets actin go, which binds to myosin, forming the bridge, and then there's the sliding filament theory, and contraction occurs. One important point is that once it's done, then you need to have the relaxation period, so the calcium ions are taken back into the sarcoplasmic reticulum, and you have, again, like you said, the period of recovery is when the potassium ions enter, and then you have an upward current of calcium and sodium, so there is a negative EMF. This is achieved with the help of a pump. It's called the calcium ATPase pump, and it pumps calcium outside. Now we move on to the last bit of this video, which talks about the control of the conductive system of the heart. So we have autonomic nervous system with two components. We've got the parasympathetic nervous system and the sympathetic. Now the parasympathetic, they are antagonists, so it decreases the activity of the heart, and the sympathetic increases the activity of the whole heart. So it slows down. What does it slow down? The heart rate, the heart rhythm, the stroke volume, and in contrast, the sympathetic nervous system increases all of that. So they first act on the SN node because that is what starts the conductive system. The beta-1 adrenergic receptors are located in the heart, and it is these receptors that are stimulated by the sympathetic nervous system. They increase the permeability to sodium and calcium ions, which are needed for the conductance. And that would be it for this video. Thank you for watching.